In this video, we're going to be learning all about the intermediate value theorem. The word intermediate is helpful to think of as something in the middle. If you think about different levels of an activity, there might be a beginner level, an intermediate level, and an advanced level. That idea of intermediate being in the middle of those three options is going to be helpful for understanding intermediate value theorem. So if a function is continuous on the closed interval a to b, and f of a does not equal f of b, and we're going to say L is some value between f of a and f of b. L is some value between those two outputs. Then there must exist a number c where basically f of c is equal to L. And that can sound very technical, so we're going to take a look at a graph here to kind of understand what that's talking about. So it says the graph to the right shows the function f of x equals x squared plus 6x plus 5. So that's a very common polynomial function. We have a quadratic here, something that we're familiar with. We also know that polynomial functions are continuous. Parabolas, quadratics, they're continuous functions. So we know that basically this first part of the intermediate value theorem must be met here. We also are talking about two outputs here, one at -3 and one at +1. So we're looking at this over the interval -1, and we can tell that because of the two facts that we are given here. So taking a look at this, we see that those outputs are -4 and 0. So let's find those values on the graph. So f of -3 is -4, and f of -1 is 0. Okay. So we're just verifying those 2 points, basically verifying that those two outputs are not equal. So that's our second requirement of the intermediate value theorem. And we're saying that basically L has to be some value between them. So I'm going to just zoom in back to that graph again. We're talking about y values that are in the middle. So here we have the y value of -4. Here we have the y value of 0. All of these y values are in the middle of -4 and 0. So for instance, we have -3, -2, -1, but of course all of the non-integer values within there as well. So this is basically saying that there must be a value then where the output is -2. And we can verify that, right? If you think about how I scribbled on the graph there, between -4 and 0, we have that value of -2. So this is because -2 is between -4 and 0. So at some point from -4 to 0, we must be passing through -2. And we know that basically because the function is continuous. That is a key element for the intermediate value theorem to be applied, that you have a continuous function. Again, we're thinking about intermediate as in the middle. And again, -2 is in the middle or between -4 and 0. Let's take a look at a real life example just to understand it with a different context. If the outside temperature is 62 degrees at 8 a.m., and it's 78 degrees at noon, and let's assume temperature varies continuously, then at some time between 8 a.m. and noon, it was exactly 72 degrees. So since 72 is between 62 and 78, again, that word between is very key here, we basically can say that the intermediate value theorem is verifying that at some point, 72-degree temperature outside must have occurred between 8 a.m. and noon. All right, let's take a look at some non-real life examples here. So number 1 says, given the function f of x equals x cubed minus 4x plus 1, explain why f of x must have a 0 in the interval 0 to 1. So whenever we're looking at this must have, we want to think in calculus like, okay, we're probably referencing a theorem that can verify this. And of course, in this lesson, we're talking about intermediate value theorem. So first, let's talk about the first requirement. Is this function continuous? Yes, this is a cubic function. It's a polynomial. So I know that f of x is continuous. So I'm going to start writing that here. Then our other requirement was that the two outputs of the interval were not equal. So if I evaluate 0 and 1 in this function, f of 0 is going to give me 1, and f of 1 is going to give me -2. Right? If I take those inputs and plug them into f of x. Then basically, according to the intermediate value theorem, there must be a 0 over the interval 0 to 1. Now keep in mind what this must have a 0 means. If a function has a 0, that means the y value is 0. So that's where like f of c is equal to 0. So think about this. We're going from -2 to +1. So definitely from the -2 to 1, if the function's continuous, we will be passing through the y value of 0. Let's take a look at a tabular question. So number 2 says below is a table for a continuous function f of x, where select values are shown. On the interval -3 to 3, must there be a value of x for which f of x equals 12? So we know it's continuous because it tells us, right? So our first requirement for intermediate value theorem is met. If we look at our outputs, we can see that they're different. Right, so our endpoints at -3 and 3, that's the closed interval we're given. Those are different values, so we know our requirements for intermediate value theorem have been accomplished here. So let's start by writing out those technicalities. So I'm going to kind of repeat what I said in the last question, basically. So since f of x is continuous, and you could write it a couple ways. You could basically say what f of -3 is and f of 3 is, or you could just talk about them being different. Either one is okay here. And let's think about those two outputs. We're being asked in this problem about 12. Is 12 between -6 and 27? Yes. So that basically verifies that there must be a value x where f of x equals 12 according to the intermediate value theorem. Okay, let's move on to number 3. Below is a table for a continuous function f of x. So again, we're getting our continuity basically out of the way here. Select values are shown. We're given the closed interval -5 to 8. If we look, those outputs are not equal. Great, that's what we want. And this question is a little different. It just says, what is the minimum number of zeros? So we don't need a big fancy explanation here. We just basically are going to answer how many zeros must occur. And remember, basically that's where f of x is equal to 0. So I'm just going to zoom in a bit on this table here. And let's go across the table. We're going to be looking at the y values and thinking to ourselves, could the y value of 0 have happened? So first we're traveling from -2 to 5. Are we passing 0 along the way there? Yes. So basically we know that we have a 0 in here. From 5 to -1, are we passing through the y value of 0? Yep, we are again. If we look from -1 to -6, are we passing through y equals 0 or f of x equals 0? No, we're in the negatives. Now, it's possible, of course, that we are, right? So we don't know. There could be values between 4 and 7 where the function's going up and down and up and down. But that's why this question, you can even see right here in the corner, is asking for the minimum number of zeros. Basically, what can we be totally sure of from this table? And then again, over here from -6 to 3, we are definitely passing through 0. So the minimum number of zeros in this problem would be 3. All right, last question in this video, number 4. The height of a tree at time t in years is given by a continuous function, h of t. H of t represents the height of the tree. Select values are given in the table below. Over the interval 1 to 10, does the time t exist where h of t equals 13? So let's talk about our requirements to use the intermediate value theorem in our explanation. We know the function has to be continuous. Okay, we know that for sure. And we know that the outputs of the interval, so h of 1 here is 5, h of 10 here is 2. We know that those can't be equal. But there's one little caveat to this question here, is that remember that in the beginning of this video, we talked about intermediate means in the middle. And we're trying to explain the y value being 13. And when I look at these two outputs over here, 5 and 2, 13 is not in the middle of them. So what I'm going to do on this question is I'm actually going to look at a subinterval of that closed interval. So if I take a look at my table of values and I kind of like focus in on the points 5, 11 and 8, 15, I can see that we must have 13 somewhere in here, right? I don't know exactly what x value it occurs at or what t value, but I know that basically 13 must be passed on the function between 11 to 15. So when I go and write my explanation, I'm going to say since h of t is continuous, and then I'm going to use the subinterval here. And h of 5 is 11, h of 8 is 15. Then, according to the intermediate value theorem, and then I'm going to kind of repeat the end of the question, a time t exists such that h of t equals 13. Just one other note on number 4 is I had chose to use the interval 5 to 8, but if you had also used 8 to 10, that would also be correct here because between those outputs of 15 and 2, we would definitely be passing 13.